basic elementary signals. First, we want to know about basic elementary signals. So, like these elementary signals are like ABCDs. So, by using ABCDs only we can make words. So, by using these words we can make a sentence. Suppose this signal we can treat as sentence. First, we have to know the sentence. We are having some words like this duration 0 to 1. We can consider some word, and I have to before word I want to know letters. So these are the you can consider as letters. So in signals and systems we are having some basic elementary signals. So that's why the signals is called elementary signals. So we are having some standard signals, like the first signal is unit step signal, that is represented by U of t. So second signal is unit ramp signal, that is represented by R of t. Unit parabolic signal, that is represented by P of t. And a unit impulse signal, that is represented by Dirac delta of t. This is called Dirac delta of t. Next one is real exponential signal. Like that we are having complex exponential signals. Like that we are having sinusoidal signals. The sinusoidal signals are very, very important in our communication system. Suppose if we are going to discuss about modulation technique, so there we are choosing sinusoidal signal. So why it is important, I will tell you later. Next we are having sync signal. So and another signal is a signum function. So these are the basic elementary signals. So the name of the signal. So how U of t, how we can draw a U of t signal. So U of t signal, the graph is like this. Suppose if you consider x-axis is a time period, y-axis is a amplitude. So this is called a coordinate system. If the signal having amplitude 1 above the or 0, so this is not 0, this is the initial point. So at initial point or origin onwards, if the signal having unit amplitude, here unit, why it is called unit means, so unit means not only one, some value, some amplitude. So it may be 1. Suppose if you multiply it with 0.5 into U of t, you can consider 0.5 into 1, the amplitude is 0.5. So in default case I am considering, so this U of t signal, this means 1 into U of t. So this is called amplitude. So this one is the amplitude. That amplitude is above the origin. So if U of t is equal to 1 when t greater than or equal to 0, so that means the value is 1 above the 0, and the same the value is the amplitude is 0 below the origin or initial time. So if you represent a signal like this, so this is called unit step signal. So if you perform integration for the U of t signal like that, so suppose if you perform U of t is equal to 1 when t greater than or equal to 0, 0 when t less than 0. If you perform integration, so 0 to t, you will get another signal. So integration of U of t with respect to dt in between 0 to t. Why we are choosing 0 to t? In 0 to t I am having information 1. In 0 below I don't have any information. So that's why I am integrating a signal in between 0 to t. In 0 to t, U of t amplitude is 1 dt. So integration of 1 is a small t or small x, and here I am integrating the signal with respect to t. That's why I am considering t 0 to t. So if I put limits t minus 0, 0. So here I am getting output is small t. So this is called, so here the output is t. So you represent. Here small a is called one scaling factor. If you consider a is equal to 1, then t. I am getting t only. T is here amplitude, not time period. T is amplitude. So if I get amplitude t, so if t is equal to 0, the amplitude is 0. If t is equal to 1, the amplitude is 1. If t is equal to 2, the amplitude is 2. So at whatever time, at the same time, if I am getting same type of amplitude, then the signal looks like, so 0 to t I am having signal like this. It's like a slope. So I am getting this result. So this signal is represented